Okay, today I am going to explain how to solve partial differential equation. Before that, you should know the types of partial differential equation. For your level, you will get only two types. See here, in this partial differential equation, how many independent variables are there? See here, we have only one. X is the independent variable. Or instead of x, you may get y also. Dou square z by dou y square plus dou z by dou y plus z is equal to 0. That may be x or y. You have only one independent variable. In this case, we have to convert PDE into ODE, means ordinary differential equation. After that, you know how to find solution of the second and higher order linear differential equation, that is complementary function plus particular integral, like that. Okay. Now come to second one. How many independent variables are there? We have x and y, two independent variables. See, x and y, two independent variables. In this case, to solve this differential equation, we use direct integration method. Okay. Now we come to the first one. Solution of PDE with one independent variable. See, this is your partial differential equation with one independent variable. Convert this partial differential equation into ordinary differential equation. See, dou square z by dou x square can be written as d square z by dx square plus dz by dx plus z is equal to 0. Okay, this is your homogeneous linear differential equation. Okay, this can be written as like this: d square plus d plus 1. Okay, by taking z common, we get d square plus d plus 1 is equal to 0. This is your polynomial operator. Write the auxiliary equation using polynomial operator. Replace d by m and equating to 0. Find the roots. Find the roots. Roots are imaginary. Minus 1 by 2 plus or minus root 3 by 2 I. Depending on the roots, write the complementary function. Okay. Actually, complementary function is e power minus 1 by 2 x c1 cos root 3 by 2x plus c2 sin root 3 by 2x. Here you should write solution in terms of x because x is the independent variable. Okay. Next, pi is 0 because differential equation is homogeneous. Now, general solution is only CF. But this is the solution of ordinary differential equation. But you have to write the solution of partial differential equation. To write the solution of partial differential equation, you have to replace, see here, C1 and C2. What are C1 and C2? C1 and C2 are the arbitrary constants. Okay. Replace C1 and C2 by function of y, f of y and g of y, because while finding the partial derivative of z with respect to x, we treat y constant. Okay. In the solution, instead of constants, write function of y, f of y and g of y. Since you have two arbitrary constants, replace two functions of y. That's it. This is your solution. Okay. Now, come to the second one. Solve this PDE. In this PDE, we have independent variable as y with condition. Given that y, when y is equal to 0, z is e power x and dou z by dou y is e power minus x. Okay, these two conditions are used to find the arbitrary functions. Say for example, in the previous one, here f of y and g of y are the constants. To find these two constants, we use conditions. Okay, here conditions are y, when y is 0, z is e power x and dou z by dou y is e power minus x. Consider the given differential equation. This differential equation can be written like this. See, dou square z by dou y square is equal to z. You transfer and convert into ordinary differential equation. Because we have only one independent variable. What is the independent variable here? Y. X constant. Okay. Since y is the independent variable, see, write this one as in terms of differential operator, d square z minus z is equal to 0. Take z common, we get d square minus 1. D square minus 1 is the polynomial operator. Now write the auxiliary equation. Find the roots. Roots are 1 and minus 1, real and distinct. Now write the CF. C1 e power 1 y. Why? Because y is the independent variable. You should write solution in terms of y. But in the previous problem, since x is independent variable, we write the solution in terms of x. Here, y is independent variable, write the solution in terms of y. Okay, C1 e power y plus C2 e power minus y. Got it? Then Pi is 0. Write the general solution. C1 e power y plus C2 e power minus y plus 0. 0 is Pi. Okay. Now replace C1 and C2 by f of x and g of x, because while differentiating z partially with respect to y, we treat x constant how many times? 2 times. So therefore take f of x and g of x instead of C1 and C2. Therefore solution is z f of x e power y plus g of x e power minus y is the solution. But you have to find f of x and g of x using the given condition. When y is equal to 0, z is e power x and dou z by dou y is e power minus x. Okay, we can replace first condition. See, z is e power x and when y is equal to 0 in this equation. Okay, now by substituting y is equal to 0 and z is equal to e power minus x, sorry, e power x. See, this is your solution. Put z is equal to e power x at y is equal to 0. See, in place of z, take e power x. F of x, y is 0, g of x, e power minus 0. E power x, e power 0 is 1, e power minus 0 is 1. Okay, then we get f of x plus g of x is e power x. Similarly, to apply second condition, what is the second condition? Dou z by dou y is equal to e power minus x at y is equal to 0. That means to apply this condition, you have to differentiate z partially with respect to y. Okay, differentiate this. When you differentiate with respect to y, dou z by dou y in the left hand side, f of x is constant, the derivative of e power y is e power y only, plus g of x, derivative of e power minus y is e power minus y into minus 1. Then we get minus g of x into e power minus y. Apply this condition. Left hand side, e power minus x is equal to f of x e power 0 minus g of x e power minus 0. Then we get e power minus x is equal to f of x minus g of x. F of x minus g of x is e power minus x. Okay. By applying first condition, we get this equation. Second condition, this equation. By solving for f of x and g of x, we get f of x is e power x plus e power minus x divided by 2. This can be done as cos hx. And if you subtract these two equations, we get g of x. G of x is e power x minus e power minus x divided by 2. This is your sin hx. Now substitute f of x and g of x in the solution. That gives a solution of the given PDE with the given conditions. Okay, now come to this one. Dou square z by dou x square is equal to a square z. Given that when x is equal to 0, dou z by dou x is a sin y and z is 0. When x is equal to 0, these two are the conditions. Z is equal to 0 and dou z by dou x is a sin y. Okay, same as previous problem. This is your given PDE. Convert into ODE. Then you can write it as d square z minus a square z is equal to 0. D square minus a square is a polynomial operator. M square minus a square is equal to 0 is the auxiliary equation. Find the roots. Roots are a and minus a. Okay. Then write the CF. CF is C1 e power ax because x is independent variable. Okay. Ax plus C2 e power minus ax. Pi 0. Write the general solution. After that, replace C1 and C2 by f of y and g of y. Because while finding dou square z by dou x square, we treat y constant 2 times. Replace C1 and C2 by f of x, f of y and g of y. Now find f of y and g of y by using given condition. First condition is z is equal to 0 when x is equal to 0. Now apply the first condition. Z is 0 when x is equal to 0. Then we get f of y plus g of y is 0. This is your first equation. Similarly, to apply second condition, what is second condition? Dou z by dou x is equal to a sin y. To apply dou z by dou x, differentiate z with respect to x partially. Okay. After differentiating with respect to x, we get dou z by dou x is like this. A into f of y e power x minus g of y e power minus x. Now apply the conditions. After applying the condition, we get f of y minus g of y is sin y. Now, by using these two equations, solve for f of y and g of y. Okay, if we add it, we get 2 f of y is equal to sin y, and f of y is 1 by 2 sin y. Okay, similarly, come to the next simplification. Okay, from the first equation, from this equation, see, f of y plus g of y is equal to 0. F of y is minus g of y, or g of y is minus f of y. Okay, since we get f of y, easily we can find g of y. What is g of y? G of y is minus f of y. Since g of y is 1 by 2 sin y, f of y is 1 by 2 sin y, g of y is minus 1 by 2 sin y. Substitute in the given, that is z, solution of the PDE. Replace f of y and g of y with 1 by 2 sin y and minus 1 by 2 sin y, then we get this solution. Okay, next one. See, dou square u by dou x square plus u is equal to 0, given that u of 0 comma y is e power 1 by 2 means, here what is the independent variable? X. That means, see, u is always function of x and y. That means 0 comma y means when x is equal to 0, u is e power 1 by 2. Okay, suppose if it is u of x comma 0, then when y is equal to 0, u is e power 1 by 2, like that. Okay, and second condition is dou u by dou x is 0 comma y is equal to 1, means when x is equal to 0, dou u by dou x is 1. Okay, now come to the given problem. Convert into ODE, write the auxiliary equation. This is your polynomial operator. Write the auxiliary equation, find the roots. Since roots are imaginary, plus or minus I, that means 0 plus or minus I, write the CF. Okay, CF is C1 cos x plus C2 sin x. Pi is 0, U is this one. Why it is in terms of x? Because of x is independent variable. Okay, now replace C1 and C2 by f of y and g of y. Now use two conditions, u of 0 comma y is equal to e power 1 by 2 and dou u by dou x 0 comma y is 1 to find f of y and g of y. Okay, here by applying first condition we get f of y is minus 1 by 2. By applying the second condition we get g of y is 1. Now substitute in u. Finally u is e power 1 by 2 cos x plus sin x is the solution. Okay, next one. See, solve dou square z by dou x square plus 3 dou z by dou x minus 4z is equal to 0, given that z of 0 comma y is 1. That means when x is equal to 0, z is 1. Next, when x is equal to 0, dou z by dou x is y. Okay, same as previous problem. Write the given PDE, convert into ODE, polynomial operator, auxiliary equation, find the roots, write the CF. Since it is homogeneous, Pi is 0. General solution, CF plus Pi. Here, what is the dependent variable? Z. You should write Z is equal to C1 e power x plus C2 e power minus 4x. And replace C1 and C2 by f of y and g of y, because x is independent variable. Okay. Now, by applying the first condition, solve, substitute and simplify, we get f of y plus g of y is equal to 1. By applying second condition, to apply second condition, we have to differentiate with respect to what? Differentiate with respect to x partially. Okay, differentiate it and apply the second condition. Okay, then we get one more equation, that is f of y minus 4g of y is equal to y. By simplifying first and second equation, we get f of y is 4 plus y by 5 and g of y is 1 minus y by 5. Okay, substitute f of y and g of y in z. Then finally we get solution of the given partial differential equation with the given conditions. Okay, this is about PDE with one independent variable. In the next class, I will explain PDE with two independent variables. Okay.